right, ladies and gentlemen, it is Mrs. Smith here, and we are back at it with lesson 2-4, exponents and division this time. So we've already done exponents and multiplication, so now we're moving into exponents and division. So the I can statement today is I can divide powers with the same base. Just like we started out multiplication, we're going to talk about kind of the long way, the process behind it, of how the rule came to be. So let's go ahead and interpret what x to the 7th power means. X to the 7th power means x times x times x times x times x times x. Let's see, 1, 2, 3, 4, 5, 6, 7. Over, and then it says x to the 5th. So 1, 2, 3, 4, 5. And you're pretty familiar with that. Now, what happens when you have x over x? All right, maybe you're not sure. What would happen if I had 6 over 6? You did this in the fraction world. If you have 6 over 6, it's equal to what? It's equal to 1. So if I had x over x, what do you think it's equal to? Hopefully you said 1, because it is. So what happens is I have a bunch of these x divided by x, because that's really what this is over here, x divided by x. So this is going to be a 1 here and a 1 here. I have the same thing here, x over x. So that's going to be a 1 and a 1. They kind of cancel each other out. And x over x, cancel each other out. I have a 1 and a 1. And of course I can put these multiply signs in between because that still remains the same. These kind of cancel each other out, and it'd be times 1 over 1. And these kind of cancel each other out, and it's times 1 over 1. And then I have an x and an x. So now if I actually did the multiplication, 1 times 1 times 1 times 1 times 1 times x times x. If I actually calculate that, that would be x, and then there's 2 of them, x squared, over, and then on the bottom I have 1 times 1 times 1 times 1 times 1, which would be over 1. And x squared over 1, you guys know anything over the first power is just the number in the numerator, the number on top. So my answer is x squared. Okay, let's do the same thing with this problem down here. So I have a w 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. Over a w 4 times. 1, 2, 3, 4. Okay, so again, cancel. This is a 1 and a 1. Cancel, a 1 and a 1. Cancel, a 1 and a 1. Cancel, a 1 and a 1. So I have 1 times 1 times 1 times 1 times w times w times w times w, and that would equal w to the 4th over a 1 times 1 times 1 times 1, and that's all that's there, over 1. And w to the 4th is equal, over 1 is equal to w to the 4th. All right, so what'd you notice? I ask you that same thing with the multiplication. What do you notice? What do you notice going on? What do you notice from here to your answer? What do you notice from the w to the 8th over w to the 4th and your answer? What do you notice? Hopefully you said, it looks like they're subtracting the exponents, because that's exactly what's happening. You keep the base the same, and I guess I don't need a comma there, but and you subtract the exponents. So keep the base the same and you subtract the exponents. So it says to divide powers with the same base. To divide non-zero numbers or variables with the same non-zero base, you keep the base the same and subtract the exponents. So subtract the exponents. Now I want to point out right here, it says if the exponent is negative, follow the negative exponent rules. That's going to be important eventually. And you know how to do negative exponents because that's what we did back a few days ago. So here we go. We're going to do several examples. Number 1, you have x to the 9th over x to the 3rd. Now I certainly do not mind if you want to write it like we did up here with the x's and the w's. If you want to do that, you can. Or if you follow the rules, keep the base the same, which would be x, and you subtract 9 minus 3. So you're actually doing 9 minus 3, and 9 minus 3 is 6. So it'd be x to the 6th power, okay? How about number 2? What if you have y to the 3rd over y? Now that's one of those that doesn't have an exponent. If it doesn't have an exponent, you could put in that ghostly Gladys 1, right? So you keep the base the same, which is y, and you subtract the exponents. 3 minus 1, that's really what I'm doing, is 2. So it's y to the 2nd power. Number 3, what if I don't have a variable? Now I have a number. 8 to the 6th power over 8. And again, if there's nothing there, we can put a 1 as an exponent. And you have keep the base the same, just the same. And then 6 minus 1 is 5. 8 to the 5th power. Nothing different. Okay. Number 4. How about 7 to the 3rd over 7 to the 2nd? So that would be 7, and then 3 minus 2 is 1. Now, do we usually have 7 to the 1st power? Not usually. Usually it's just plain old 7. Okay, so let me take up a notch. What if I have 7x to the 8th power over 7x to the 4th power? Now my base is a little bit different. My base is actually 7x. So therefore, I'm going to make my base 7x, use those parentheses, and then I subtract 8 minus 4, which is 4. Okay. Notice I kept the parentheses. Don't forget them, okay, because that makes a difference. Same thing here. Negative 1 to the 4th power, excuse me, not the 4th power, the 9th power, and negative 1 to the 3rd power. So again, keep your base the same. Keep those parentheses, negative 1, and you have 9 minus 3, which is 6. Dun, da, da, da. All right, so now I think we're ready to take it up another notch. What if you have 8 to the 3rd divided by 8 to the 6th? 8 to the 3rd divided by 8 to the 6th. Now, I want to start with the longer expanded form like we did up above for this one. So 8 to the 3rd means 8 times 8 times 8. Okay? 8 to the 6th means 8 times 8 times 8 times 8 times 8 times 8. Okay? So, just like before, these are both going to go to a 1. Just like before, these both go to a 1. I'll put in my dots for multiply. These both go to a 1, and I multiply. Now, notice I have 1 times 1 times 1, which would equal on the top 1. On the bottom, I have 1 times 1 times 1, and then I have 8 times 8 times 8. So that'd be 8 to the 3rd power. Now, I can go ahead in my calculator and calculate 8 to the 3rd power, and 8 to the 3rd power would be 512. And of course, you can use your calculator to calculate that. Now, that's the long way. What if I use this rule? Keep the base the same and then subtract the exponents. So let's do that. Let's do it right here underneath. So I keep the base the same, and I'm going to subtract. What is 3 minus 6? So that's where you have to be careful. It's 3 minus 6. Well, that would be 8 to the negative 3rd power. And if you remember, it says subtract the exponents. If the exponent is negative, right here, if the exponent is negative, follow the negative exponent rules. Meaning, I can't keep it negative. So my first rule was to put a 1 under it. My second rule was to flip it. When you flip it, you drop the negative sign on the exponent. Ooh, looking similar, looking the same. See that? And so then I have one more step, which would be 1 and 8 to the 3rd power, which would be 512. And then looky here and looky here. You have identical answers. So I just wanted to show you kind of the math behind it. That's what I was doing here with all of the long form. And here, you just have to change it and make it get rid of the negative sign in the exponent. All right. So here we go, number 8. Number 8 is y to the 8th over y to the 14th. Okay, so again, I could go ahead and do y times y, 4, 5, 6, 7, 8, over 14. Ooh, that's a lot of them. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And of course, these cancel. Cancel, 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 cancel. And so that gives me, maybe make my line a little bit longer, 1 over, and then I have 1, 2, 3, 4, 5, 6. 1 over y to the 6th. If I did the shortcut way, keep the base the same, subtract the exponents, which would be 8 minus 14. 8 minus 14. 8 minus 14 is negative 6. Can't have a negative exponent, so I put a 1 under it. I flip it, and when I flip it, I drop the negative sign, and lo and behold, by golly gee whizzers, they're the same. They're the same. Okay? All right. Well, what would happen if I didn't have variables this time, and I just had a number? 6 to the 4th divided by 6 to the 7th. So again, I could write it out like this, but I think you're starting to get the idea. Keep the base the same, and then subtract. 4 minus 7 is negative 3. But I can't keep it negative 3, so I put a 1 under it. I flip it, and when I flip it, I drop the negative sign, but I'm not quite done yet because now I have to calculate 6 to the 3rd power. Can't leave it as an exponent, and 6 to the 3rd power is dun, da, 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 216. All right. Let's do another one. Number 10. X over x to the 9th. Now, there's not anything there, so I could make this a 1. And so now I'm going to keep the base the same. Oops. Forgot I was in red. And then I have to subtract 1 minus 9. And 1 minus 9 is negative 8. Put a 1 under it. Flip it, and it'd be 1 over x to the 8th. Dun, da, da, da. Done. Now, of course, they like to try to write things like this and fool you. How about something like this? 5 divided by 5 to the 3rd power. Doesn't make a difference which way it's written, if it's written as a fraction or as a division, old school sign here. So there was nothing there for an exponent, so I put a 1 there. I keep the base the same, which would be 5. I subtract the exponents, which would be 1 minus 3, which would be negative 2. And of course, I got to put a 1 under it. I flip it. When I flip it, I drop the negative sign. And 5 to the 2nd power would be, dun, da, 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 1 over 25. All right. So now I have another little thing that I want you to do. Kind of takes it up a notch, makes it a little more difficult. And it's find the missing base and power. Find the missing base and power. So for that, I'm looking at something like this. Say number 12. What if I have 8 to the 7th over blank equals 8 to the 5th? So 8 to the 7th over blank equals 8 to the 5th. So you know your base is 8, so that means it's going to be 8 here. Now 7 minus what is really what I'm doing. 7 minus what, I'm going to put in a variable because we don't know, equals, and it says right here, it equals 5. So 7 minus what equals 5? Hopefully you said 2. So in that box you would have 8 to the 2nd power. Good. How about number 13? And again, remember, you can stop the video and try these problems out yourself. That would be a good idea. So keep the base the same. So this is a 5, this is a 5, so this has got to be a 5. And then 10 minus what is going to give us 3? 10 minus, hopefully you said 7, because that's really what it's saying. 10 minus what? Equals 3. So that'd be 5 to the 7th power. All right, now I'm going to change it up a little bit. The box this time is going to be on top. So now you've got x to the 7th power equals x squared. Now be careful. The base isn't too hard. Obviously, you know that's an x, but now you got to think about the exponents. Now, be careful this time because it's blank minus 7 equals 2, and the answer is not 5. Because is 5 minus 7 2? It is not. So what minus 7 would give us 2? Now, of course, we could solve this little equation if you wanted to do that. And what's 7 plus 2? It's 9. Or you might just know that off the top of your head. X to the 9th divided by x to the 7th would give us x to the 2nd. All right, here we go. Number 15. Another one like that. Blank over 8 to the 5th equals 8 to the 3rd. Blank over 8 to the 5th equals 8 to the 3rd. Okay, what do you think? Did you say 8 to the 8th? I hope you did, because 8 minus 5 gives you 3. All right, feeling pretty confident? Hopefully you said yes. I'm going to take it up another notch. Oh boy. Number 16. What about this? Blank over 4 to the 4th equals 1/16. Hey, wait a minute. What's going on here? What do you know about 16? 16's a perfect square. 16's a perfect square. And it's a perfect square if you take the square root of it. What's the square root of it? Hopefully you said 4. So that means 4 times 4, or 4 squared, equals 16. Did you think of that? But did you notice that this is 1/16? How could I get a 1/16? Could I make this 4 to the negative 2? If I put a 1 under it and I flipped it, that'd give me 4 squared, and then that would be 1 over 16. Isn't that what I need? So that's what I need. I need, when I keep the base the same, so we know it's going to be a 4, and I subtract these two exponents, I have to get a negative 2. So what minus 4, just minus 4, gives me negative 2? Did you say 2? Is 2 minus 4 a negative 2 that I could flip and make 16? Ooh, that was a tough one. But that is correct. Here we go. Number 17. Blank over 7 to the 3rd equals 7 to the 8th. Oh, I took it easy on you. No more toughies like that last one, but I liked that last one. Keep the base the same, which is 7. What minus 3 is 8? And hopefully you said 7 to the 11th power. 7 to the 11. All right, can you do it? Hopefully you can.